MCAT just taught me how to do this.
Did you just start the recording?
I did.
Good.
Okay, I hope I did. Anyway, hello, beautiful people. It is so good to see you again. It's been a little while since we hosted a meetup. It's been a long while since I hosted a meetup here at Portworx, so this is a little bit of an experiment, so thanks for bearing with us.
And that's because you've been running around the country.
Yeah, we've been running around the world. We were in Vancouver at the OpenStack Summit. Who gets my newsletters? Did you guys all read? I sent one out this morning with links to everything. When you sign up for our user group, you have the ability to also hear from me, and I send you, discounts to conferences and links to things. Anyway, we all just got back from the OpenStack Summit. We have the sessions are all posted. You can go to openstack.org, and there's a link to all the videos, and I sent that link out this morning as well. Some of you noticed there was a little rebranding of the user group, which is actually a really cool thing. Went over very well at the summit. We are now cloud native open infra, which is pretty cool. And yay, yeah! The guys asked me about that on the Cube, and I gave a longer explanation of why we did that. But you know why we did that, because you've been here following the content with me for the last 2 years, and we just wanted a name that was a little bit more reflective of the content we've been delivering. But we had a little fun with the guys on the Cube. So I sent that link up to you also in email this morning. But that actually makes the CNCF is now a Greystar meetup, which means I now also, as well as running the world's largest OpenStack meetup, I run the world's largest CNCF meetup. So for a little while, I think that the Cube meetups are going pretty fast too. But I am still the North American ambassador, yes. My name is Lisa, by the way, so if I'm getting Q&A already, we're going to save the Q&A until the end, and I want most of the Q&A to go to our amazing presenters. We might do a little Ask Eric Anything session. But the other thing I want to say is we have another meetup next week. We're going to be at Velocity on the 12th, so if anyone's going to the Velocity conference, or if you're not going to the Velocity conference, in San Jose. It's a fairly similar topic, but it might focus less on Kube, more on Docker. Eric is also going to be presenting, so if you can't get enough of Eric Han, you can go down to the Velocity conference next week. It's Dave Nielsen's meetup group with the DevOps, so I haven't posted it yet. And then the week after that, on June 19th, Robert Starmer is back, and he's going to be talking about, he's going to tell you how to stop throwing money away on cloud. It's going to be actually a pretty good one. And that one's back at Global Logic. Those of you that remember the last meetup we did when Rackspace did the Kubernetes at Scale meetup, that was at Global Logic. So we're back there on June 19th. And then next week up at DockerCon, if anyone's up in the city, the Kata Container team and the OpenStack Foundation are hosting a little meet and greet. So you can go up and understand how you can join and contribute to the Kata Container project and to and join that community. So that should be a really cool meetup too. So that is, I will post that on the calendar as well, but that also went out in the newsletter this morning. I could not be happier to have the amazing privilege of working with Eric Han. It's actually kind of one of the reasons I joined this company a few months ago. We all know Eric from his days at Google when he was launching GKE, one of the co-founders of GKE and the original Kubernetes product manager. So we're super lucky to have him here at Portworx. And so he's going to talk to you today with Dan Garfield about running stateful applications in Kubernetes. Where's Dan?
Dan's making the live demo.
Okay.
Live, right?
Yeah. Dan's awesome too. Dan is my kind of engineer. He's an engineering-minded person who absolutely understands the value of marketing as well, and sort of how I roll also. So you're kind of lucky today. You've got some two amazing people. And so I want you to challenge them during the Q&A. We were going to just do a whole Ask Eric Anything session, but we thought we'd throw a little content at you first, because we get asked the question all the time about stateful applications and containers. Y'all are very familiar with stateless applications and containers, I'm sure. It gets a little harder when it's stateful, and especially on day 2 and 3. So that's what we're going to talk to you about today. Who is running Kubernetes in production right now? 5 hands. Who is planning on running Kubernetes? Okay, good. All right. That's, you're not behind, people. That's actually kind of in line with about the number of hands I usually get. I thought it was going to be a little bit more, though, since you made your way to this meetup. But anyway, are you guys ready, or do you have it? Okay.
Dan's walking here just in time.
Oh, wonderful. You missed all the really, really nice things I just said about you.
Oh, nice.
So you guys can just make up names and tell them. So please give Eric Han and Dan Garfield a warm applause.
Yeah, I'll log in. So Dan will set up, but thank you guys for all being here. And A great shout out to Lisa for organizing what is an amazing community. And congrats on renaming it and rebranding it for the next big generation of technology. So I'm Eric. Thank you guys for being here. I'd love for you guys to give me questions as we go. So let's keep it interactive. It's not a webinar. So feel free to just shout out things. If they get too hard, we might pause. But Dan is from CodeFresh, and he's been here 3 times. Yeah. So we love working with Dan. We were both EKS launch partners. So Dan, do you want to say anything?
I'm Dan. And what's really exciting about tonight's demo and presentation is that we actually delayed starting a little bit because I broke it right before. This is the best time to break something. It's a more real world scenario. So everybody cross your fingers that it's going to work. We tested it several times. I think it will.
It's going to be live and interactive. It'll be relevant to tonight with Game 3 on.
Yes, exactly. The only other thing I'd say is I think just out of the audience, how many people are running Kubernetes today?
Oh my gosh, I just asked you.
Oh, you already did all this? You did the whole thing? Okay.
Well, it's okay. You were fixing it down.
All right, how many people are running Kubernetes today? One of you? 5?
2 more raise their hands when you ask.
Okay.
You guys just started running it just now?
That's true. That's true.
Gotcha. Okay. How many people are using Jenkins for their flow? Okay. What's everybody else using?
Circle CI. TeamCity.
Circle CI, TeamCity, CodeShip, Blank Stairs. Okay. They're tools that you use for CI/CD. It's okay. I'll explain afterwards. Don't worry about it.
So Dan, while you're logging in, actually, I'll do my intro, then you can switch.
Yeah, please go ahead.
So I'm Eric. I'm from Portworx. So thank you guys again for being here. If you don't know what Portworx is, I'll just start by explaining that I think we're all here because containers and DevOps is supposed to enable agility. But oftentimes we find that it's the infrastructure that holds people back. So if you're ever there saying, I'm adopting DevOps, I want to be able to go into production faster, I want intent-based computing, and you find infrastructure is holding you back, oftentimes it's storage. And so from our perspective, we've been solving that with customers. We've been around since 2014. Our VP of Engineering, Venkat, has asked me to plug in that we're hiring. So please go talk to Venkat afterwards. At the same time, we've been very fortunate to work with a lot of enterprise customers. I think it's just by nature of the fact that containers is how people are building the next set of applications. It is the largest enterprises that are doing so, and the cloud native app companies that are starting off. So it's been a lot of fun to watch the ecosystem evolve from how do I launch Docker Run to how do I schedule to how do I actually run a full stateful application and distributed system. So with that, we'll actually spend a lot of time talking about very basic concepts just so we can lead into what's a pretty interactive demo. So the basic concepts will cover pods, PVCs, and we'll actually go one step further to a 300 level and talk about snapshots and how snapshots work and data flow, just to make it real. Yeah. But before I advance to that, Dan, do you want to just add anything else?
Yeah, so basically I work for CodeFresh. I don't know how many of you are familiar with CodeFresh. Our thesis is that if you want to build sort of production-ready containers, you want to deploy them to Kubernetes, that you're going to want a tool that matches that, a CI and a CD tool that matches that. So you can think of CodeFresh a little bit like Jenkins plus Spinnaker plus like Docker Hub. That's kind of what CodeFresh is, except we're sort of optimized for Kubernetes, optimized for Helm, optimized for sort of that container native approach. So that's what we do. And so the reason I know anything about Kubernetes is because I'm part of CodeFresh and just been totally focused on it. So I don't know like a lot of the old world anymore at this point. I mean, but
I'll do a page back to the old world.
Yeah, that's great. That's perfect. Yeah. So CodeFresh, we've been around we launched about 1.5 years ago, 18 months ago. And we've got customers like HP, ARM, the microservice, you guys know who ARM is. they're one of our customers. So we have a mix of customers both in the enterprise as well as like mid-size. But today's there's a lot of really functional knowledge stuff. There's a little bit of like product demo stuff, but most of this is applicable, across the board.
Generalizable to any ecosystem you run in. So Dan, is it okay if I just keep going?
Yeah, just keep going.
Okay. I'll skip this. This is the agenda. I think we've already mentioned it. I think.
Just gonna mute this guy.
Oh, it's the other person I can't use. Okay. So this is not the intent here to go over what every stateful application could be. But I think the key thing is, one of our customers made this point, Michael Richmond from NEO, is that the only stateless application is Hello World. So if I look at a system and I think about what people are running, every application has state. It's just a choice of how you handle it. Do you defer to the cloud provider? Do you run it in a legacy system? Do you bring it into containers? So it's very hard, including when we do our demo with the pipeline, it's very hard to do it without some form of state. And so you guys can ask me any question, but we see all kinds. Elasticsearch, Kafka, Cassandra, they all have some form of data, and how you manage the data is extremely important, not just from a high availability, but from a protection, replication, doing AZ perspective. And this is my page back to, because I'm a little older than Dan, what I would say is the before world, and this is true for me. I was actually part of this team. 2 points to anyone who can name this device. It's always in my desk.
Zoom.
So, Dan, I was going to give you the Zune and say, this is what all the kids are running now.
Oh, sweet!
It's actually a Zune original one. And this is actually how we deployed Zune Web Services. So back 10 years ago, maybe even longer, I was the Zune Web Services PM. And what we used to do is every server had one application it ran. It either ran IAS, MySQL in this case, or some job logic. And those servers could only do one thing. It was very hard to deploy. And it was true for me that my first daughter was born the night we deployed. I told my wife I'd be back in 10 minutes after we did everything, and it took 5 days for us to deploy. And what actually ended up happening is that we didn't have the right patterns for how to deploy repeatably. We didn't understand density. We didn't understand scaling. And so I think if you ask what is working in the old world or what is the downsides, the downsides are really that you're tying one application to a machine, one application to a VM. It's very rigid. It's hard to scale. It's hard, and a lot of the management becomes just tribal things that you do by hand. So it's not very adaptable, especially when we're all trying to do more applications more quickly. And so the cost of applications is extremely high when it comes to the monolithic approach. So that's just the old world before Dan was out of school. So I'm a little bit older.
Before I drop my Zune in a bowl
Before
of
you drop
water.
your Zune, that's there's more Zunes in my house than people, but but if I talk about stateful containers or containers themselves, I think the key thing is that, well, how did containers get invented, or what was the main focus? It's a lot of things like I cannot predict the demand or the applications that run in my environment. And I cannot, in the sense that, if I'm at Google and I have ad campaign, I cannot say what is the mix of apps going to be. Or if I'm doing IoT, or if I'm even just running an internal container as a service, I don't want to control or limit the choice my developers have. So they're going to bring in new stacks. They're going to have their own requirements. And you no longer want to say one container per machine. You actually want to do 20 containers. And our customers are doing 5, 20, 40, 90 containers per server. Right? So that's where people are going. And so what we find in this case is that what it really allows them to do is they really have a lot better automation. They can rely on Kubernetes and other schedulers to manage, but they also need something when it comes to persistence. And that's in some ways where we feel like customers will have the best chance of lowering their cost per application. And in some ways, that's the benefit. So just to get to the education piece, what I wanted to walk through are some of the key concepts within Kubernetes. And this part does not apply to Portworx. So in all these cases, I'll use examples that would apply to any cloud you have. And the first thing I would describe is all those containers, to make them declarative or intent-based. What I want to do is I want to describe the intent, and I'll do so in various specs. And I'll actually give you the YAMLs in a second. But if I gave you all the YAMLs, in some ways, it's kind of hard to organize as a thought. So if I took a step back and said, what are these YAMLs all describe? What I would say is that you have a user, they're going to invoke or access an application. If later on I could draw services, but there's a pod. A pod basically says, I have one or more containers. And these containers are always co-lifed. They're co-lifed in the sense that if I deploy this pod, that pod has to be repeatedly deployed, and every container within it has the same lifecycle. Right? So if I tear down the pod, I tear down all its containers. The original reason for this is you might have scenarios like I have a web server and I have a content management server, content management feeding system that'll feed the web server, and they don't really make sense independently. I can't have a web server without content and content that doesn't get picked up. There's no point, so you put them together in a pod. But the moment you can put them into the pod, what you realize is you're already running multiple containers on a server. And those containers will actually create volumes. The way you access the volumes is the idea is that I'll use a persistent volume claim, and we'll do that quite a bit in Dan's demo. And a PVC is really a ticket that says this is the pod, this pod wants to use this volume. So the volume itself ends up coming back to you, and the volume itself allows a level of indirection. The indirection is really something called a storage class. And that becomes important because what a storage class then allows a vendor like Portworx or anyone else is that you start to describe your infrastructure level requirements below the line, and above the line, the application is portable. So applications are portable in the sense that if I was back at Zoom and I was describing the environment I want to run in and the applications I'm running, I could take that pod definition and with very minimal changes, run them inside one data center, move it to another data center, or move it to public cloud. So that portability benefit was always there. So I have to have a layer that describes applications in a self-enclosed fashion. And that's part of the power that I think people are losing. And when it comes to the infrastructure, I can't do this completely in the vacuum. I have to tie it together. So an infrastructure allows me to say the best things that an infrastructure could offer to an application. So from an infrastructure point of view, a storage class can start to advertise, I expose things like encryption, I expose things like high availability, and it starts to become where I put the values that the infrastructure provider is offering. And that's why to give it an example, the amount of storage you actually want to use or capacity is up here in the application definition, because that's application level logic. The storage class is saying, I can satisfy it, but I can satisfy it with this kind of classes of storage. And the volume that you get back is a best match by Kubernetes.
Yeah, one of the things that I like about Portworx as a storage class provider is that I can use it on any cloud.
Yeah.
Whereas there might be some nuances of the storage class that I pick on like GKE versus whatever I'm going to get on AWS versus Azure versus OpenShift, Redshift, whatever, Open Redshift.
Open Redshift.
That's it.
That's a new one.
Nailed it.
Yes.
And so it's nice to have something that I know that I can reliably use across any cloud or even like a local sort of my own home, like my own cluster, so that I have complete sort of
that's true. And
mirroring
so that happens,
my environments.
Thank you for saying that. That happens in the sense that our customers will use Portworx with multiple flavors of Kubernetes, but they'll also use this across multiple clouds. So with Dan, we did the EKS announcement, and then next week we'll do another large public cloud announcement.
Yeah. So it sounds like you're saying that you can have a storage even in a public cloud and your applications running in a private cloud.
I would say this. You could do that, but what I'm describing here is in some ways how you describe it. And so the idea is that you could take it, package it all up, and launch it in another environment, and they're all co-located or they're all in the same.
But I just wondered that that's possible to do something like that.
It is possible. Your latency will be impacted, but that's just device physics. Yeah. And we can spend more time. I think that's a good question.
Okay.
So this is just actually to walk through concretely, and I can send these slides, but the idea is what the actual manifest would look like when it comes to Postgres is Postgres will say, I'm a pod, right? And there's a few things I've omitted, like the API versions, you actually have to satisfy it. But then at that point, you say, I'm going to use the container I choose. So your developers, when they run this, they'll say, I want this Postgres, I want this MySQL. And it's basically the container image. So this is why Docker and all the container images are still very relevant. And then from the volumes, it says, I want to use this persistent volume. The persistent volume then starts to describe the actual size. So size belongs here because this is all the stuff that gets portable and it belongs with the application. And then it will reference a storage class. And so to Dan's point, our storage class can run anywhere. But even here, I'm using a generic example. This storage class might say, I offer this file system, this high availability, this level of replication protection. And then the persistent volume is what's returned. And that's all internal logic. But the idea is these things become the basis for how you define your application, describe your infrastructure, and tie the two together. Yeah. We'll actually demo some of this.
And the other thing about the storage class is it can have extra functionality exposed. So in Kubernetes, we have this idea of CRDs, these custom defined resources. I'm like moving too slow to that. Underclocked. These sort of custom defined resources, and so these things can have extra capabilities. So coming to get to know Portworx from my side, you get all these abilities like, I can create like a snapshot, and like I can like instantly create a snapshot and restore it somewhere else. And so there's all this extra sort of functionality where in the container world, we maybe didn't have that yet. So it's cool because you get all of that extra stuff. And I don't know all of the storage class classes out there and all the nuances of them.
Yeah.
But most of them don't provide like a snapshot, something like that. That seems unique.
Yeah.
Yeah. For the snapshots stored on the same node that the databases.
They are, and they can be also backed up. Oh, actually,
that's sort of like
it can be backed. They can also be moved off cluster.
Yeah, we'll talk about that more in a second.
They're local and remote, so I'll describe that in actually 2 slides if that's okay. So actually, this is something that describes the demo that Dan's going to give. Is if this is a 200 level description of what happens, this is actually going to take it to a 300 level. So I assume all prior knowledge. And the idea is we can also take a persistent volume, as Dan's pointing out, and it has original data, and we'll use a snapshot to create another set, an application sit on top. So we can now start to create workflow for if I'm in production and I realize I have an issue, I can create a snapshot using live data without unmounting the original application. And then that data is available for me to go run my CI tests and say, this is the right set. And so we'll actually have you guys test it with us in a second. If that makes sense.
When you mentioned a snapshot in Kubernetes cluster, cluster-wide snapshots or just one volume?
Yeah, so the snapshots, that depends on your infrastructure provider. And for us, it's cluster-wide, right? For us, it's important in this ecosystem that everything has to be cluster-wide.
I think he means, are you creating a snapshot of the entire cluster state or just a volume? And actually, it's just a volume.
You might be right. The alternative interpretation that I took, and I could be wrong.
Is that available?
Is it available across it?
I think more practically, right? People run application under namespace, right?
Yeah.
So I assume
this is actually namespace scoped.
Okay.
Yeah, that's a higher level question. So that is true. Everything. So if everyone understands namespaces becomes a protection mechanism, and it's also a way to create a virtual cluster, if you will. So you can't really broach a namespace in the sense that if you have team A in a namespace and team B, team A doesn't access team B's data, and that is true in this flow as well as these respect namespaces.
Question.
Yeah.
Yeah, when you take a snapshot, do you take a snapshot of each individual synchronous database?
So that is
three
okay.
Three snapshots rather than just one.
So I'll give you 2 answers. One is, does Portworx do it? Yes, right. We support consistency groups. In the technology or generically across the ecosystem, that doesn't necessarily exist. So as much as I'm describing what generically exists, the answer would be not necessarily. In our case, we do. So we do support consistency groups.
And the whole point of this flow that we're talking about is really related to how you validate changes that go into production. And what we want to do is say, we have some real data that's live. And I want to make sure that my test environment matches my live environment as much as possible. So instead of loading it with dummy data, I'm going to snapshot the live data and actually load it in to my test instance so that when I do run my integration testing, it's running against the real, it's the full-blown real application with all the real data. It's the real deal. It's just not exposed to anybody externally, right? And so then when we're running integration testing on it, there's really no chance that we can have any inconsistency between those two environments. So that's like kind of the why of this. And one of the cool, and I don't want to step on your toes, but one of the really interesting things about this volume snapshot, if you think about like a database that's like 4 gigs, and you're like, okay, I'm going to snapshot that. How long do you expect that to take? Maybe a few minutes, right? Well, actually, in this case, what it does is it creates a copy on write snapshot. So it copies it instantly. It's like 0.002 milliseconds. I mean, it's wicked fast. And then only as the live database diverges from the snapshot does it actually start to write data. So this means that for like our purposes of testing and validating with live data, there's no latency. It doesn't introduce any extra time into our process, really.
Thank you for that. There's a question back there.
To go back to the previous slide.
Please. Yeah.
In that, you talked about 8 GB, right? If I want to go that to, say, 50 GB, what's the process here?
So you can resize. So we do support resizing. So I'll explain a couple of other reasons why. There's 2 parts of this. Is this 8 GB, you can actually respond with a volume that's larger. So this is a min spec. And so you can actually come back and you can actually update this and resize. That's the other part is if you look in Kubernetes, you can start to do things like Kubernetes edit, and you can edit these objects. And it'll actually, we should probably do that with his demo, is that you can take a PV, a persistent volume claim, and you can start to edit it on the fly.
And for the second one, it's a nice feature to have the next slide.
Yes.
It's a nice feature to have the production data, but it's not PCI compliant because you're not masking the data. You are giving the.
So I'll disagree, right? Because within the namespace, we're scoping it within the whole entire ACL system. And we're also describing it as part of, we do have ways of pairing clusters and moving data. And I think that might be the following question to what you would ask, if I understand your thought flow, right? And so the answer is you have to have the same PCI level of trust, right? And so PCI ends up becoming about how I set my security boundaries and I enforce the policies. And we can spend more time on if I'm missing anything. And so as long as you have that, we start to create ACLs and RBAC workflows that restrict it. Now, what the point here is this is not a way to do a route around all those things. ROOT, right?
No, you're cloning the data without masking the data.
Right, but that's about field level encryption. Your question seems to become, am I encrypting the field level? And for PCII or PCI compliance?
PCI.
Right, but PCI compliance, this is more about the data is encrypted and it's within the same trust domain. Right, data is still moving. It's not restricted to the application. It's the boundary can be the whole cluster if you want. Right? And there may be a nuance to PCI that I'm missing here. But
another way of thinking about it is that the test actually isn't running in some off test environment that people have all the keys to. It's running in the same plane as our production stuff. So it has the same level of protection, it has the same level of RBAC, has the same level of all that stuff. So if this is vulnerable, then your prod is vulnerable too.
Yeah, happy to. And I think from the PCI HIPAA world, the most important thing is to start to create audit trails and records. And this allows for that flow.
It's more access, who has access to the data.
That's right. And I haven't drawn the namespace, but somebody here asked me namespaces, and namespace becomes how I restrict access. So all these things have to be within a single namespace. And we could spend more time on if that satisfies that part, right?
Yeah, you'll see more in the demo. Yeah.
You can think of it as this: if I run a command, the command only responds within the level that I'm allowed, and the way that you scope that is with a namespace. So,
back to the last slide. How many of those can you do through OpenStack?
Through OpenStack. So I don't know OpenStack's limits.
I know it can make volumes, but I don't know if it can do snapshots or volume claims.
Actually, given that this audience has a lot of OpenStack knowledge, does anyone know the limits on Cinder or OpenStack? How many it can create? Okay. I think your question starts to
whether it can even create a claim.
Oh, I see. I would say...
I know it can create a volume.
Yeah. It actually goes back to Dan's point. There's actually about 6 or 7 entry Kubernetes drivers, and what's happening, this is a separate topic, we're starting to externalize the driver support, and I'm sure OpenStack, we'd have to look at one of them. I actually don't remember if it is, but I don't want to claim that I know. We'll have to ask somebody else.
It's stupid that you have to go through and make a whole bunch of volumes just in case somebody wants to make a claim.
Oh, I'll say this, at least in our case, and it's others can do this too, is the volume creation is dynamic. It's created as the application is running.
Yeah, so in what we're going to do...
In a second too.
Yeah, go ahead.
Okay, so this is just a summary. So to your question, you asked me earlier, how do we do it? This is actually how Portworx does it, right? Or this is what Portworx's point of view is that the top problems that people have with stateful containers, and this is a mix of various customers, and we talked about who we have, as well as use cases and environments, and the answer becomes, there's at least 3 top common problems. One is high availability. How do I support if a disk fails, if a server fails, if a rack fails, or an ASIC fails? What do I do? The second one is really about how do I do things like snapshots, backups, and I think that's what you're starting to ask. So your point being that if others don't do it, that's in some ways why we are doing it, because our customers have been the key drivers. And the last one is, now that I'm running 20, 40 multiple containers per server that all have needs of storage, how do I control the performance requirements? I don't want to run and find out that the least important apps is taking the most amount of IOPS. Right? So those are the kinds of things. And one thing I'll say is that the goal here is not more complexity. We're talking about stateful containers, persistent volume claims. I actually think that when we do the demo, you'll see that it's actually quite streamlined from a user experience point of view. Because what we're relying on is all the complexities handled by the technology. In our case, by Portworx, and in Dan's case, by the whole entire CI system that they've put together. That makes it very seamless. So just to explain what we do and then get to the demo, we do aggregate. So your questions start to become, how do we support failover? How do we export resizing, expanding? Is that we run ourselves as a container. In that container, we run into a cluster formation. As a cluster, we're able to aggregate the capacity. We do things like unifying the control so that when you do Kubernetes commands, everything's seamless. And at the same time, all our volumes are container granular. So you're no longer relying on a VMDK or a storage device that supports many things to satisfy your data needs. You're actually creating container granular volumes every single time. And the whole entire workflow is integrated with scheduling, both from provisioning to your question about how volumes are created and also the application lifecycle, which Dan will demonstrate. And the other part here is you have to integrate with, in our case, you have to integrate with scheduling. So as the schedulers are running and launching, we're able to do things like introspect about where the scheduler wants to place an application and inform that this is the best location if you want certain performance controls. Right. Go ahead.
The virtual block devices span multiple physical disk drives.
So they do span multiple physical disk drives. And I don't know if I said virtual block device, but that is right. It's a virtual block device. So actually under Linux, under /dev, you'll see our virtual blocks devices created. And we would have taken over ones that didn't have some application on top of a file system.
How about applications which use in-memory databases?
Sure. Any specific example like Spark or? Yeah. So what we tend to find
is DRAM, not storage.
I understand. Yeah.
Oh yeah, we should repeat the question because it is on recording.
Oh,
I forgot.
I think we've missed maybe 20.
We've missed 20. Yeah.
So the most recent question, thanks Dan, is what happens with applications that are in memory? The answer is that there's a few things. There are times where there's applications that don't do anything to disks, right? And our fundamental approach is you should be able to run any workload on the same cluster. So some of the cluster will use in-memory, some will use disk. And there are applications that are kind of a mix where they don't have a lot of requirements. Elasticsearch is actually kind of a nice example. And they don't mind where they get capacity from. So they're kind of in between in the sense that they use it, but they have a little bit different tolerance. But to answer your strict question, the answer is in-memory ones that never write, they'll never have to require using us, and we're just something already on the system. For applications that think they're in memory, they oftentimes also do spill to disk. And when they spill to disk, it's very important that they spill to high-performing disks, because you don't want an in-memory system to spill to a spinning hard drive, and suddenly its rotation is caused a degradation because something that was supposed to be in memory expanded beyond the actual allowed footprint, and now you're spilling to slow disk.
Yeah, and on some level, like anytime you're using Kubernetes, I'm kind of a big believer in chaos engineering, which is like you should be able to have your application running, and you should be able to run a script that randomly goes around killing pods, and you shouldn't lose anything from your users. And that's more a question about how is your application architected more than it is about like how it's interacting with the disk per se. Because if you can do that and it's like, well, they need to hit this specific pod because this one has the memory, then it's like, okay, well, we should probably step back and actually design this a little bit differently. The pod should be able to die at any time. Like just I don't want to belabor the point, but this is just kind of a funny anecdote. I've talked to some people who are doing Java, and one of the common jobs in Java is garbage collection. And once they moved to Kubernetes, what they did is they turned off garbage collection and they let the pods just suicide themselves. Because it's actually faster to start up a new pod than to run garbage collection. It's actually more efficient. So that's actually like a sort of container native approach to this, right? So once you're there, you're there. Anyway, let's
I like that example. I mean, it is as you said, right? This has to be intent-based. You don't want it to be based on understanding device level things.
Yeah.
Once you understand it, you should be able to promote upward. So this is just one of those points is that you really want it to be seamless. You want to be able to understand that on an intent basis, I can say this application wants to run with data local, and that's something that we also enable through scheduler extensions. And then just one last slide about Portworx so I can explain how the demo is going to work is that from our perspective, our cloud native storage layer is actually integrated with things like HashiCorp Vault, Kubernetes secrets, so you can actually supply and support bring your own keys, and all data will be encrypted. And that starts the process towards PCI. I'm sure there's more we can spend time on. And then the backup to the off-cluster point, the backups can be to object storage and restore. Right, so all these things are automated from the sake of, I wanted to do it from a compute with Kubernetes. Now I need to from a data perspective, and we do so with Portworx. Right? So actually, this ties into what we'll show a lot with CodeFresh is that if I had to describe what we're going to do, it becomes like Dan's pointing is that we're going to take Kubernetes scheduling Postgres databases. We actually don't even care where those are scheduled. And when it creates, it's actually going to create volumes within Portworx. And then we're going to trigger the snapshots and use the data, and it's all going to be automated and managed through through the continuous delivery system. Through the continuous delivery system.
Through CodeFresh is what it's, yeah.
Somebody said some other word that starts.
I'm going to get you a NASCAR jacket.
So from that perspective, it's going to be automated through CodeFresh and their template.
That's right. All right. So to introduce the application that we're going to use tonight, it's a lot of Docker people are familiar with this application. It's called the voting app. And you can grab my copy off of Today Was Awesome. So just remember how you felt about today. You'll remember it. Today Was Awesome / example voting app. And this is a great example because this is a complex sort of 12-factor app, right? It's got multiple microservices. It's all containerized. It's actually all packaged as Helm. Is everybody familiar with Helm? Yeah. Maybe like, does anybody want like one word on what Helm is? What the Helm that is?
Is it a package manager?
Yeah, package manager for Kubernetes applications. Okay, so what I have here is each of these kind of components. They each their own service. One is Python, one's Node, one's Redis, one's Postgres, one's .NET. And if we hit the each of these have their own containers associated with them, and each of these are actually their own Helm chart. And then they're packaged all together as a chart of charts. And so I can say Helm install voting app, and it will pull all of these things with all their configuration, and it will install it in whatever, with whatever values that I pass to it, whatever variables I want to use. So I like this example a lot because it sort of is like a more real life scenario. Once you get up, you can still use this once you have like 150 microservices, and it will still, it's still functional at that kind of scale. There are some nuances to how you might test an application that has 150 microservices that maybe you don't want to spin it up every time you want to run some tests against it, right? So I'm happy to talk to you more about sort of scalable testing strategies afterwards. But in this case, I think most people are, if you're in the realm of like, hey, I don't mind spinning this up and tearing it down, then this demo is kind of more for your speed. Let's see, and then will you stop sharing, and then I will start sharing.
Before you do that, I just have a super quick question. Sorry, I have to ask you this. Did everybody sign in when they came in, or I saw a couple people kind of rush through? Did anybody think past the thing and not sign when they came in? Anyone? One? Can I just have you sign super quick? Just put your name. Sorry. Insurance.
So something that Dan's mentioned that I also like about Helm is that it creates versioning, so that it's very easy for me to track the versions of what I'm deploying. So I can think of deployment as a version item that I can then, and Dan will show this, I can use it to install and delete in a very version sense.
Yeah, precisely. Okay, so this is the demo that we built and want to do tonight. Basically, we're going to make a commit. And it doesn't really matter what version of control we're using. Tonight we're using GitHub, but you could be using Bitbucket or GitLab, whatever. Some more people tonight using GitLab than yesterday, maybe. For no good reason, I should say. For no good reason. Have some faith, people. We're then going to build our images and our chart. Now, I mentioned this is a Helm chart. What I actually do, this is sort of a mono repo setup, and anytime I make a change, I'm actually going to build all of my images again. There's some discussion for why we might want to do that. One of them is that means that I tag all my images with my commit SHA, which means that all my images will always match all my commits. And I'm still going to validate the image before I push the new version, even though nothing should have changed in it, but it's still going to be validated. And this just puts you in a state where like your Git is basically in sync with what's in production. This is sort of another topic we call GitOps. which is a whole universe for another time. But once we do that, we're going to clone our live data. And clone here is sort of in quotes because, remember, we actually don't write any data. We create a snapshot that references a sort of virtual volume that is basically the state of the database when we created the snapshot. And it will only write when changes to the live database happen. So there's very little performance hit here. It's going to deploy our entire Helm chart to a one-off environment. Why a one-off environment? Well, a lot of organizations get into this stage of like, oh, okay, I'm going to have like my staging server. And then like you add like a few more engineers and they're like, oh, I'm just waiting for the staging server. And you're like, oh, I'm just going to add another staging server. And then you add another staging server. And then it's like, how many staging servers do I have? And are they all running properly? And have they kept them up to date? And oh, this one's broken. I got to go fix it. Ah! We're in the container world. Who cares? Let's just spin it up and tear it down. We don't have to worry about that. Right? So we're going to make a one-off environment that we can toss after 5 minutes of testing, right? That we can validate and throw away. And this is going to be scalable. So even if we have 1,000 engineers running this and they're all popping up like their corners of their microservice universe with their Helm chart, we should be looking at a very efficient use of resources because it's really only live while it's being used and then it's torn down. And then we're going to run some functional tests. Now tonight, I actually disabled the functional tests because I was debugging some of my volume snapshotting stuff, but I'll show you what it would look like if I had run them. And then we're going to deploy to production because we've validated it, and then we're going to remove the one-off environment. And that's what we're going to do. So let's go into the demo. And everybody cross your fingers majorly. I'm used to doing like demo fixes down to the last minute, but this one was a little bit more hairy than usual. I messed things up a little bit more major way.
This one we got.
All right, so let's look at our application first. This is just, by the way, this is CodeFresh. You can see I've got my repositories, which have all of my workflows, pipelines associated with them. You've got builds, images, because I have a built-in Docker registry, so I can see all the images that have been built. We do this for caching reasons, but also for just convenience reasons. You can add any external registry and push and pull and knock yourself out, but having the built-in one actually has just a ton of advantages that I could enumerate on later. And then we have our Kubernetes integration. So you can see I'm looking at a Kubernetes cluster here. I've got all my services. I can see everything's currently running fine. I've got my production voting app, all my services here running just fine. And then I have this thing on Helm releases. So if I go over and look on Helm, and I see that there's this prod voting app, this is what we're going to work with. It was last modified 42 minutes ago. Down to the wire.
That's right.
And here's my application. So here's the vote. And if you have your phone with you, what I'm going to do is ask anybody who would like to vote on this. I'm going to give you about 30 seconds to vote on this.
So we're voting on
Warriors versus Cavs. Oops. So who you think is going to win? Now, I know that it would just be 100% Warriors, so I've preloaded a bunch of data in there as well. But go ahead and vote on it for a second, and then we're going to make a change. And what we're going to do tonight for our change is we're just going to add like a little bit of text, just validate our text change. But it will showcase how we build and then push and deploy this thing on into production. So I can give you.
Only vote once. This is
well, if you open up a new window, yeah, it doesn't check your like IP or anything. So if you do a new incognito window, you can go and vote. All right, voting's going to close here in a second, and we will go look at the results. I guess we could actually watch the results come in. So right now we're at 84 votes, 60% for the Warriors, 40% for the Cavs, 86 votes, still coming in. Great. All right, so we'll keep this open, and if our demo works as expected, we'll see the vote number match from the moment we create our snapshot. So let's make this small.
What's your count? Go.
And put it over here. Hide that. All right. So now what I'll do is I'll kick off the pipeline, and then we'll go and look and see what it's doing. So I'm going to open up my code editor here, and I'm just going to modify Oh wait, I don't want to change this one. I want to do. Oh yeah, let's change this one. So where it says warriors, I noticed that it's wrapping. And what we're going to do to make that more convenient is we're going to add a hyphen. That way you know that it's supposed to wrap. See? Makes sense. Oh, let's add a breaking space too. So it'll be war, yours. Yeah, that'll fit. All right, so let's commit that. And we'll do our commit. Add useless hyphen. Perfect. Origin. All right, and if I go over and I look at my builds, we're going to see it kick off here. Okay,
you guys
so
also automate all the infrastructure aspects as well.
Oh, like working with Kubernetes? Yeah. So here it's going to kick off, and first thing it will do, we saw our diagram earlier, is it's going to clone the repo, right? Then this step is actually going to build the images concurrently. So we have 3 images that we need to rebuild every time. And so what this step does is it fires off 3 like sub pipelines whose only job it is to build images. And so I basically pass it a matrix set of values, and it's going to go and build those images. And it's going to wait for all 3 of those images to be built before moving on to the next step. So this is a nice thing about sort of the infrastructure. Kubernetes, CodeFresh is actually built on top of Kubernetes. And so for us to be able to handle like a scalable sort of, doing 50 jobs or 100 jobs concurrently, not a problem. It's instantly scales up and isn't an issue. Here it's creating the snapshots. These snapshots are already created. And here we can see them coming in, and they will already be bound and ready to go. And now it's deployed into staging. And once it deploys into staging, we just need to wait for the IP addresses to come online. So once that comes online, then it will run the testing, and then it will deploy into production. So while it's doing that, I'm going to show you just an example of how these images are going to look. So if I go back here, so this is actually one of the images that I built during my pipeline. I hope everybody can see that okay. Make it just a little bit bigger. This is an image that I built in my pipeline. And one of the things about having the built-in Docker registry is we can use this standard called Open Grapheus. I don't know if anybody's familiar with it, but basically it's a way of annotating information onto images. And the idea here is images are normally kind of a black box. Who made this image? Where did it come from? Who worked on it? Did it pass through all the correct hands? Did somebody build this locally and push it, which would be the worst possible ever thing that could happen? Or was it built by my CI/CD system? So that whole audit trail is going to be visible inside of CodeFresh because CodeFresh is taking care of the entire CI/CD pipeline, and we can actually get all that information. So I can see that I'm the one that created it, right, just now by making my commit, so we can see who worked on the commit. And then this is an example that I did earlier. So you can see that there's a whole bunch of information. This one was deployed to production. This one, UI testing was successful. There are links to some UI testing reports. And if I click on those, they'll take me into like the reporting information of all my integrated tools that I have. So here I can see the test that passed. This one's using Testum, and I can actually see the screenshots of what the test actually ran. And I could play it back if I wanted to. I could also see that this one has a security report, so it's integrated with Twistlock, and I actually ran security scans on it. I could use this with Artifactory and X-Ray. What's your question?
What's the technology for annotating?
Open Grapheus. Open and Graepheas.
Yes, sorry.
Yeah, never accuse the open source community of great names that are easy to type. What's that?
Is this only a SaaS model, or you also have on-prem?
No, CodeFresh is also offered on-prem. I recommend just getting started with the SaaS to try things out because it's just easier. But we do have on-prem, and we also have hybrid, where we can actually deploy an agent into your cluster, and you can still use the SaaS kind of version of CodeFresh, but all your code and all of your jobs all stay inside of your cluster, which is a great option for a lot of people where they don't want to take on worrying about keeping the CodeFresh infrastructure up and running on their own stuff. But yeah, we have customers like HPE is using us on-prem, full on-prem. And then we have like hybrid customers like Giphy, who does, I think, 5 billion GIFs a day. They use CodeFresh and hybrid. So yeah, we've got security reports. We even have like a Jira ticket here. And if I wanted to understand like what change even brought this all about, I can actually click right on the commit shot and it will take me straight into GitHub where I can see the diff of what created this build to kick off in the first place. And so from like what we call this problem in the container world is provenance. Provenance is where does something come from? And this solves provenance for us. And if you're coming in from like a DevOps standpoint, and you're like, hey, something's broken. Well, like I can go through and, I open up Kubernetes and I can see everything that's running and I can see what image is running and I can click on the image and see what change was made and all the validation that was done. And so I basically have all the information right here that I need to debug this thing or to send it over to whoever needs to debug it, right? Like you get instant blame, in other words.
Is that a Jira ticket as well?
Yeah. Oh yeah, there was a Jira ticket. So if I go back. Yeah, there's a Jira ticket here. Boom. So we got a Jira ticket. So having all this information is available is really useful, and we can also see all of the image layers, which is useful for debugging and things. One more thing that I'll mention on the build side, when we ran this build, and here it is, it took about 2.5 minutes. Most of that, 1.5 minutes of that was just waiting for the endpoint to come online. So we could have solved that with like a static ingress or something. But when we built the images, we built all 3 of those images in 41 seconds. That's because CodeFresh has spent thousands of hours optimizing how we build images. We will build images faster than anybody else. Challenge me on it and bring whatever build system you're using and try it. I dare you, and I would love to see you do it faster. We do it because we cache all the layers. We actually take the build volume that you build on and we actually reattach it onto pipelines when you run them again so you can actually pull in the data. And then one of the things that makes this whole thing container native and really novel compared to sort of like the second wave CI systems like a Circle CI or a first wave CI system like Jenkins is that each of these steps actually runs inside of its own container. And they all get a volume attached to them, so you can write variables and read them out later and do that kind of thing. But it gives you the ability to use any set of software, any versions of software in different steps, and you have that isolation. So this is just like a really sort of container native way of approaching the continuous delivery, continuous integration process. Anyway, so I jabbered on for a while, but did this thing actually deploy? Did it work? Now, what I did is I disabled the step where it destroys the environment so we can go and look at it. Otherwise, it would just be up for about 30 seconds and then die. So let's go look at that. If I go over to my Helm releases, we're going to see the staging voting app now instead of the prod voting app. And I don't remember what number we left off. Hopefully nobody voted after the snapshot was created because we were at 93 votes. Let's go and look at the staging app. And we'll see if this loaded properly.
We should have a drum roll.
86.
There we go, 93. So we have parity. Woo! Yes! Thank you. This is the part that I wanted to make sure was going to work perfectly right before we did the demo. So in our staging instance, we actually have the exact same data, but you can see that I have my change that I made in there. And if I refresh production, we'll see that change reflected. Okay, so that worked properly. But if I went over to, if I come back to my release and look at my prod instance, if I had run into any issues, if this had gone to production and I found that there was like a performance issue that somehow, even though I ran performance testing on this thing, we're always 99.999% sure, and then there's every once in a while you get that 0.0001% thing that happens where you have to roll back. And if I go to my history here, I can see all of the versions of my Helm chart. This isn't the version of my microservice. It's the version of my entire application stack. So all my images that change, any configuration that changed, I actually have a diff on the Helm chart. In this case, I didn't change any of the chart. All I did was replace the image values. And I can actually issue a rollback right from here. And this will roll back to my previous version that I did just before this demo. So that's running right now, and it'll be done within 15 or so seconds. I can also just see what's in my Helm chart that was last deployed, as well as the values that were passed at runtime. And then I can get the entire manifests of everything that was actually deployed into production. And the nice thing about this is I have my application packaged, and I can snapshot it, and I can roll back, and I can pull all that stuff, and everything will just work smoothly. And if I go back and look, my release came back. If I go back and look at prod here, and we open up the result page, we'll see that it has rolled back. So I'm back to where I was right before I started the demo.
That's very cool.
So with that being said, I think the real exciting thing about this, we did a lot of sort of validation steps, and we had a lot of examples of how we could validate our stuff. But the really cool thing is that we were able to take live data and load it in to our test instance. Now, Portworx solved the snapshotting problem for us, and the performant persistent volume and the PVC. It solved that stuff really, really well. And then CodeFresh here solved like my build infrastructure, my pipeline definition, my Kubernetes integration, my integration with Portworx, all of the automation and scripting, and then it solved Providence for me, and all of those sort of lifecycle problems. So with that being said, we do have a few minutes for questions.
You guys also solved the application deployment, rollback, and just the idea that I have complete tracking to the actual users and what they were doing. Yeah, and versioning my application, rolling back, getting the provenance. Yeah.
We do have a couple of minutes for questions, but I just want to say, in case anyone has to leave, we actually ordered a little bit more pizza also, because sorry about that. We had no idea what to expect and how hungry people would be, and there was a lot more people here than we thought. So sorry if you didn't get a piece of pizza. There is a little bit more pizza. We're going to keep it open until 8:30 for Q&A. So both Eric and Dan will be here, right?
Yes.
To take questions up until 8:30, so you can have another beer and chat. Once we're done here, though, we will move people back over to the kitchen area, if you don't mind, for Q&A. And anyway, first of all, I want to thank you guys for coming to the first, my first meetup at Portworx, so really appreciate that. Give yourselves a hand for going through traffic all the way up here. And I also really, really want to thank the about 20 Portworx volunteers that were here and that let me boss them around for about the last 4 hours, actually really the last 3 days. So I want to really thank, especially the guys who checked you in, Sam and Kyle and Nick, and then Brian and everybody who put all the chairs down, and then everybody in a Portworx shirt. You can ask lots of questions about Kubernetes or about stateful applications or any of that afterwards. So thank you, Portworx team, so much. Thank you guys.
Special shout out to Hart, who was helping me with the demo right before I got to the wire. Thank you.
Another Kubernetes expert. Hart shall also be around. So why don't we take 2 or 3 questions on the video, and then if it starts going really long, we'll wrap.
Yeah, then you can put the game up.
Yeah, 2 questions then. 2 questions for the game.
So where does your snapshots store in the same?
So, that's in one of the diagrams, right? And so what ends up happening, and it's a good question, when it's physically stored on a cluster, right? And actually the snapshot itself, if you say specifically the snapshot, it creates a new persistent volume as well. So the snapshot always becomes a reference that can later go be used for creating other persistent volumes. The snapshot specifically itself is its own object.
Yeah, so you can see here I just did like a kube control get volume snapshot, and we can see the snapshots that we just created. And those are available now, so I can put them into any PVC that I want. Basically, it'll load it into, sorry, not a PVC.
No, you're right.
PVC,
no,
So it could be different PVC than the one you were using?
No, you're right. That's the actual intent, right? So think of this as a way to generate new PVs.
Right.
And the PVC is a way to get that new PV. So you're right. The snapshot becomes this intermediary that I can then go create volumes that I want. So in this case, the snapshot, at least in this language, is not.
What about the scope? Like you said in the beginning, Portworx, like the storage class is, the scope is the same pod or something like that?
It's to the namespace.
It's to the namespace. Yeah, but that's actually true for the entire, that should be true for your entire tool chain, right? So the answer, and that goes back to other restrictions. Someone
going down a layer lower, we're doing a copy and write snapshot. So
Right.
The data is on the same physical blocks on the same physical disk.
Yep. The data hasn't moved.
Right. Okay. So, so one thing that strikes me is if you're doing some kind of capacity testing, you're impacting the actual physical devices that production devices are using.
So you're talking about the sake of staging and how in a staging use case, we were using the actual same set of hardware.
Right.
True. And is yours specific to the whole idea of what happens at the snapshot, or is your question more specifically about a DR?
Of the physical disk. Are you going to impact performance of production by doing testing against it? That's my actual question.
No, I understand. So the idea here is that the storage classes themselves, there's a few other variables I didn't describe, and more exhaustively, there would be notions of what's the I/O priority. And it starts to become how we balance and rebalance. So that is part of the whole entire, if I gave a whole cheat sheet of what's happening, there is balancing, rebalancing, priority, and it's for the sake of those kinds of aspects.
Good enough. My actual question is, so say the application that you're testing, part of its function is it has to persist data. Can you write more data into the file system that's of the other snapshot?
You can't append.
Yeah, I don't know which other refers to which.
Yeah, append, yeah.
Because we only made one snapshot, right? And if we wanted to get like more live data, we would create a new snapshot and load that into a new PVC and attach that to our application.
Can you make a snapshot of a snapshot?
You can, but you wouldn't make it directly of the snapshot, right? You would take a snapshot of the volume, or you would take a snapshot referencing the PVC. There's actually, what we can do afterwards is we can open up the YAMLs.
No, I've got it right here. So one of the cool things about working with Portworx is that you're actually, because they're those CRDs, those custom defined resources. I feel like I'm getting the acronym backwards.
Custom resource definition.
Yes, thank you. Custom resource definition. I was like, this doesn't make sense. Because Portworx uses a CRD, we actually, to create the snapshot, all we're doing is the kube control apply. And then we're applying the YAML. So this is the YAML right here. This is to create a snapshot for our Postgres instance. And it's so short. Like let me jazz it up maybe a little bit because it's so short. There we go, jazzed up. What it does is, it says, I want you to create a volume snapshot. This is the name of the snapshot that I want you to make. And this is the volume, the PVC that I want you to pull it from. So it's pulling from prod, right? And then when I restore it, all I'm going to do is apply my restore, which is going to be in restore. It's going to be in here. And this one is just going to say, basically take this snapshot, the one that we just made, and attach it into, using this storage class name, attach it into this PVC, into this persistent volume claim. Right. And now when I deploy my application, the PVC is sitting there, and Helm is, I've told Helm, I passed it a value that said, this is the PVC I want you to use. So when Helm does its install, or if it did an upgrade, it says, oh, that's the PVC that I need to use, attach and use. Make sense? Okay.
Can we take the rest of the questions offline, because my team is itching to actually get the game back on here. So I changed the plan. You're welcome to stay here and watch the game, or go and have another beer. But please give Eric and Dan a huge round of applause. You guys are awesome. Thank you guys for coming, and please come and ask a question, and I'm going to stop this recording.
On snapshots for a long time.